Why do you work in security? Why are you here today? I work in security because I like the idea of helping people. I think that at its core, privacy and security are about helping people get control over technology. I have privilege, and you have privilege, because we're security experts. We know how to tell the difference between HTTP and HTTPS. We know how to tell where a file came from and that it's the right file. We know how to avoid being scammed. And we have that privilege because we are security experts. But not everyone can be a security expert. Doctors are busy helping their patients. Parents are busy raising good kids. And artists are busy making the world a more beautiful place. But I still think that they deserve to have the same level of control over privacy and security settings and features that we in this room do. This is why I work on usable security for end users and why I think you should too. Now, what is usable security for end users? There's many ways to define it, but in my opinion, a security feature that a user has to interact with should be invisible when you don't need it, and helpful even to non-experts when you do. This is easier for some classes of security features. For example, if you're isolating different principles and different processes, that's easy to always be invisible. But if you're working on something that has the user in the loop, like authentication or anything with an exception or an alert, I believe this should hold true. But this is really difficult. This is really hard. To pick on my own work for a minute and the work that my team is doing, here are some recent tweets that I've seen about Chrome's HTTPS warning. Both of these people had the same problem. What's going on here is that they're trying to load a web page over HTTPS, and something went wrong. The certificate chain failed to validate. And so instead of being able to get to the website that they were trying to go to, they got an error message from Chrome instead. This is not a good user experience. It's not helpful. It's not empowering. And honestly, in this situation, it wasn't even really protecting them from anything, because there probably wasn't a real attack here. Now, I'm picking on myself here, but this is not just a Chrome problem. It's a problem that we see across the industry. We see these types of problems in other products and areas. We have trouble with, people have trouble with the unlock on their phone. People have trouble with authentication. Phishing is still a big problem, et cetera. Why is usable security so hard? Why are we still having difficulty with this idea of invisible but helpful, which I think a lot of people agree is what usable security should be? Now, this is a very complex problem, and I don't want to diminish its complexity by giving a glib response. But today I'm going to talk about one thing that comes to mind when I think about this problem, which is that usable security is a science, but not enough people treat it like a science. At Google, a motley crew of people, a mix of engineers, designers, researchers, have been treating usable security like a science. And today I'm going to tell you 3 different stories about how we used a scientific approach to security to tackle really hard usable security problems in Chrome. 2 of these stories are going to be about successes, and one of the stories is going to be about a failure. But I hope that we can learn from all 3 of them. If you don't already believe me that usable security is a science, I'm hoping that these 3 stories will convince you that it is. If you already agree with me, I hope that you can use these stories as talking points to bring back to help convince other people who you work with, other engineers, other security experts. And if you work in academia, I assume you probably already do science, maybe even science on usable security. I want to illustrate some of the gap between the science that we find useful in industry and what we're currently getting from academic research. Now, what do I mean by treating usable security like science? Well, first I mean look for specific research. Look to see if there's existing research at SUPS, at CHI, at USENIX Security that could guide how you're building a feature that puts the user in the loop. But if you can't find this research, which honestly we've found you might not be able to, you need to run your own experiments. You need to have defined controls and conditions and hypotheses that you can test. You need to take things that are nebulous, like the idea of users understanding a warning, and turn them into something that's concrete and testable. And there's also a few things that you should not do. You should not trust your gut. Your gut, my gut, we are not representative of regular users. Things that seem understandable to us or convincing to us will not generalize. And similarly, you should not trust common wisdom unless it's backed by data and research. The first story that I'm going to tell you about started about a year and a half ago. An engineer came to me and started telling me about the problem of wanting to bring rich APIs to the web. So currently, we see very rich APIs on platforms like Android and iOS, where apps can do lots of things that websites currently can't. But in many cases, web developers want to. Take notifications, for example. Until fairly recently, websites were not able to send notifications, whereas an app could. So if you were Gmail, you could build the Gmail app, and the Gmail app, even when the user is closed it, can still notify you about an incoming email message. But websites weren't able to do this. So this is one example of one of these new APIs. And what do you think about that idea? Different nerds have differences of opinion over how cool this type of new API is. If you're a web developer, it probably seems pretty cool. You can drive user engagement back to your website. You can provide features that don't require them to be looking at your website at that moment. So from that perspective, it's great. But if, strictly hypothetically speaking, you are a paranoid security person, purely hypothetically, I'm sure that doesn't apply to anyone here, you see a lot of things to be afraid of in this setup. So just looking at notifications specifically, there's the concern that they'll be spammy and obnoxious. There's the concern that they could be used for better phishing attacks. There's the concern that it just sort of might confuse people about the relationship with a website. Like, I closed it. Why is it opening again? And one of the ways that comes to mind to fix this fear is the idea of having a permission request. So what you can see here is an example of a permission request where Facebook is asking for access to the new notifications API. And it tells the user what website it is. It's Facebook. It tells you what it's requesting, which is notifications. And then you have a choice between allowing or blocking. OK, so we've kind of solved this first problem. We've given users control over a website can actually do this potentially scary thing or not. But now we have a new concern, which is the fear of annoying users. And we've probably seen from our own experiences that I don't really like it when stuff pops up on the bottom of the screen when I'm trying to use a website. That's kind of obnoxious. And there's also a good amount of prior literature telling us about a phenomenon called habituation, which is that when someone experiences the same stimuli over and over again, they pay less and less attention to each subsequent iteration. So this prior literature is telling us that there might be a negative side effect of asking people these questions over and over again. But it's not entirely clear. What does that actually mean in practice? How many permission requests is too many permission requests? What are the costs? Like, are people going to stop using Chrome? Are people going to stop using their phones? Or are people just going to be moderately annoyed for a split second before they move on? And does that prior literature even apply here? Right? It's hard to say, because prior literature focuses on full-screen warnings and showing people them over and over again in a really short period of time. But in our actual scenario, people are seeing warnings over a long period of time. We're luckily in a good position to be able to actually test this, to answer some of these questions, although not all of them, but we can answer some of them. What this is showing you here is that we've taken all the users in aggregate on one specific day and saw how they responded to the notification permission request. And then we looked back over the previous 3 months to see how many prior requests they'd seen in the previous 3 months. And what you can see here is that for people at the 0, so people who have never seen a permission request, at least not in the past 3 months, there's an almost 40% chance that they'll grant the permission request. But by the time you get down to 5 or 6 permission requests over the last 3 months, the acceptance rate has dropped to about 10%. What this is telling us is that there is a very real cost of websites requesting permissions, perhaps unnecessarily, spuriously, at bad times, for bad reasons. because people are less and less likely to grant the permission as they see more and more permission requests. And this holds true across different types of APIs, not just notifications. We see the same thing happen with geolocation, where as people see more requests over time, the likelihood that they'll accept drops from a little over 25% to well below 10%. In this situation, the common wisdom and our gut feeling that lots of permission requests were annoying and caused people to pay less attention to them turned out to be true. We substantiated that idea. But if we hadn't actually tested this, if we hadn't actually looked at it, we wouldn't have known how rapidly that occurs. And this is information that we're now able to use as input to our engineering projects to try to decrease the rate at which people see the spurious or unnecessary permission requests, so that we aren't spamming people with things that less than 10% of people are going to say yes to. The next story takes place in the land of malware warnings. Chrome relies on a service called safe browsing. Safe browsing tells Chrome when a website is known for being malicious or deceptive. And when that's the case, we show one of these warnings about the website. The warning tries to convince people not to proceed forwards to the website. Safe browsing is very accurate, so we know with fairly high likelihood that the user is going to be at risk if they proceed through the website. We don't just block people. We could, right? We could make it so people can't proceed through the website, but we still want to give people the choice. However, we want to convince them to adhere to our message that you should actually return back and do something else instead of visiting the malicious website. About 2 years ago, the adherence rate was only about 70%, and we wanted it to be closer to 90%. A higher adherence rate in this case is better, because that means more people heeded our advice to go back. So we wanted to test a few different things to see what the best way is to raise the adherence rate. And today I'm going to talk about some experiments with the headline text. The headline text is the larger text on the top, and also experiments with the malware download warning, which occurs at the bottom of Chrome when you've downloaded a warning. When you've downloaded a malicious file. We started off with a literature review. We went to look to see what are the main recommendations for what you should do if you want to increase adherence to a warning. Some of the literature recommended really useful things, like, for example, you should aim for a 6th grade reading level. This is really great advice because it's extremely specific and it's measurable. We were able to take our text, we were able to reduce the warning level using a tool, and then run with that. But other pieces of advice were a little harder to follow. For example, on one hand, be as brief as possible, and on the other hand, be extremely specific about the risk. How do you do both at once? How brief is brief enough? How specific is specific? It was kind of difficult for us to follow, but nonetheless, we still tried. We ran a series of A/B tests, also known as randomized control trials, to test out some of the different things that we gleaned from literature in an attempt to increase the adherence rates. Here are 2 examples of experiments. In these specific experiments, what we're testing is the idea that we should give people a command to follow our advice. So for example, at the top, the control is the website ahead contains malware. It's a control because it's the existing text. And then we altered it slightly so that the first condition adds go back to the end of it. We did the same in the second set of experiments. We added commands like discard this file, don't run it, to that control. And so here, each set of experiments has a hypothesis, which is that the alternate condition will do better than the control. And we randomly assign small groups of Chrome users into each of these buckets. And then over time, we could look at their adherence rates for the people who fell in the different buckets and compare them to each other. I'm emphasizing the fact that we had a control, and we had various conditions, and we had random assignment, because these are key parts of scientifically running an A/B test. Unfortunately, these 2 particular experiments had negative results. We found that adding the commands didn't actually make much of a difference. There are some small differences between the different conditions here, but they fall within the normal fluctuations that we see on a daily basis in this type of warning. I know that negative results aren't super exciting, but the reason I'm sharing them with you today is because I still think we learned a lot from this experiment. What we learned is that even if you do your best to follow previous literature, and even if in your gut, you think, oh yeah, this is totally going to work. It might actually not work. And you don't know that until you've run the experiment to see whether it works or not. If we had just gone ahead and made this change, added go back, and been like, yeah, mission accomplished, and rolled it out, well, a few months later, we would have been surprised when we discovered it didn't actually help. Instead, because we ran the experiment and because we got to find out that it didn't work, we were able to learn. And instead, we tried out other things. We tried changing the background color of the warning. We tried changing the icons. We tried changing the layout. And in the end, it turned out that changing the layout did have a positive effect on adherence. And if you'd like to learn more about how that worked, you can read our Chi paper from last year. For the third story, we're going to talk briefly about internationalization. Traditionally, historically, most previous research on warnings, on HTTPS warnings, like these up here, and like the malware warnings I was just talking about, has focused specifically on English-speaking Americans from college towns. There have been other studies on, for example, some Canadians in college towns, and also some that have used Mechanical Turk to look more broadly at Americans. But in general, it is still centered on English-speaking North Americans. And I can understand why. For practical reasons, it's much easier to run a study with the people around you. Most of my prior work has looked this way too. And this work has yielded positive results. It steered us away, us as in the broader security community, it steered us away from using passive indicators that were really small and kind of just in the corner of the browser, to instead prefer these larger full-page warnings that do, in fact, work much better. But we still see a real gap. On one hand, studying people in North America who speak English, and then on the other hand, browsers serve global audiences. So we decided to take a look at this and see what regional differences we might find. We were able to slice the malware warning adherence rates by country. And one thing I want to point out first is that we're looking at Android and Windows separately here. And this is important because the type of device you use, your operating system, is actually a confound here, because we see that people on Android adhere to warnings at consistently at a higher rate than Windows users. So we have to look at them separately. But our hypothesis here was that warning adherence rate would differ across countries. And it does turn out to be true. It does differ. In fact, you'll notice that we have a problem specifically in Japan, where Japanese users are not adhering to warnings, at least on Windows, at the same rate as other countries are. We took a look at the same thing for HTTPS error warnings. And again, we do see differences between countries, with Turkey having the highest adherence rates, and again, Japan on Windows having the lowest adherence rates. Why Turkey and Japan? I honestly don't know. And I actually would love it if people in this room could help figure out why. If you speak another language or love to travel, I think this would be a great area to look at, an important area to look at. For example, I think that looking at Turkey, we could learn maybe there's something in the way it's translated or something in how they're perceiving the warnings. Maybe we could learn from that and translate it to help the rest of the world. And also, if we look at Japan, maybe we'll find specific problems there that could improve and bring Japan up to the rest of the world in terms of adherence rates. The reason why I told this last story was because I, again, wanted to highlight the importance of how it can be your results can be surprising once you actually dig into data. If you had asked me before we started looking at statistics sliced by country, I would have guessed, well, based on stereotypes, Germans are very privacy sensitive, so I would expect higher adherence rates for Germany. And that's not actually what we ended up finding. So I'm very glad that we actually took the time to dig into this data. Usable security is science. At Google, we test ideas with clearly defined hypotheses, with experiments, and we use the results to determine what we should launch. We use experiments to figure out how to settle technical arguments about the right way to build a feature. And we look at our data over time, like in the case of those international charts I just showed you, to look at Chrome's strengths and weaknesses. If you're in industry, hopefully I've convinced you that there is merit to taking this type of approach, and given you some stories about things that are surprising or negative results that you can take back to your colleagues to demonstrate why it's important to actually test things instead of just making changes that we feel in our gut are good for users and then launching that, because it doesn't always work. And if you're in academia, I hope I've convinced you that there's still a lot of ground to cover in usable security research. There are companies like Google that are hungry for specific and actionable recommendations backed by your research that we can use to improve our products. Matthew Smith, who will be talking later today, is an excellent example of this. So I appeal to you, please respect end users by going and doing usable security as a scientific field. Thank you.